Welcome to my channel Chemical Chemistry Classes. Today we are proceeding our topic, that is purification of organic compound, in which we have studied sublimation, crystallization and distillation. Today we are going to discuss differential extraction and chromatography. First, we will understand what is differential extraction, right? Differential extraction is a technique used to separate an organic compound from an aqueous solution. In short, in this, from aqueous solution, we have to separate our organic compounds. We have to separate our organic compound from aqueous solution. This method is based on the principle that an organic compound will have higher solubility in a suitable organic solvent compared to water, and critically the organic solvent must be immiscible with water. The procedure involves shaking the aqueous solution containing the organic compound with an appropriate organic solvent in a separating funnel. As you can see in this picture, this is a separating funnel. Before extraction, there is a solvent layer, and this is an organic compound in aqueous layer. After extraction, what we get? Organic compound in a solvent layer and aqueous layer is here. From aqueous layer, organic compound is move to solvent layer, right? So this is happen because due to the difference in solubility, organic compound preferably moves into the organic layer. Since the organic solvent in water are immiscible, they form two distinct layers. As you can see, there is a two layer. One is of organic solvent and next is of water, aqueous layer, right? So the organic solvent and water are immiscible. They form two different layers. The denser layer is drained off from the bottom of the separating funnel. This is the bottom. You have to move this so that the one layer can move out easily, right? So the denser layer is drained off from the bottom of the separating funnel and leaving the other layer behind. This process can be repeated multiple times to ensure maximum extraction. The organic solvent is removed by distillation or evaporation, leaving behind the pure organic compound. For example, if phenol is dissolved in water, it can be extracted by shaking the solution with ether. That means if we take this funnel, right? So in this funnel we add phenol that is dissolved in water, and the solvent is diethyl ether, right? So the phenol is much more soluble in organic solvent than water, and the organic layer can be easily separated, as you can see in this picture also. If the organic compound has low solubility even in the chosen organic solvent, a technique called continuous extraction can be used, where what happen in this process, the same solvent is repeatedly used to extract the compound, increasing efficiency, right? So this is about the differential extraction. In this we have studied differential extraction is a technique used to separate an organic compound from an aqueous solution. Next is chromatography. Chromatography is powerful and a versatile separation technique that are widely used for separating mixture, purifying compounds and assessing the purity of substance. The name chromatography originates from the word chroma, that means color. It was initially used to separate colored plant pigments, right? So the fundamental principle of chromatography involves two phases. that is stationary phase, and other one is, first one is stationary phase, other one is mobile phase. Stationary phase, this is a fixed phase. This phase is a fixed phase that which can be a solid like silica gel or a liquid like water trapped in paper fiber. Mobile phase, from their name, this is a moving phase which can be liquid or a gas that flows over the stationary phase. The separation of components in a mixture occur because different compounds exhibit varying degree of affinity for the stationary phase and the mobile phase. Components that have a strong interaction with the stationary phase will move more slowly, while those with a stronger interaction with mobile phase will move faster. That leads to their separation. Chromatography can broadly classified into two main types, that is absorption and other is partition. Right. So first we understand what is absorption chromatography. This type of chromatography is based on the principle that different compounds are absorbed to different extent on an absorbent. Absorbent means stationary phase. Commonly used adsorbents include silica gel or alumina. There are two types of absorption chromatography, that is column and thin layer. First one is column and next is thin layer. In column chromatography, the stationary phase is packed into a vertical glass tube like this. This is a tube, right? So in this column, what happened? The stationary phase, that means the adsorbent, is packed in this tube, right, into vertical glass tube like a column. The mixture to be separated is applied to the top. This funnel is attached here. So mixture is added from the top. An appropriate eluent means a mobile phase or a liquid or mixture of liquid is then allowed to flow down the column. As the eluent moves, the component of the mixture are adsorbed and desorbed repeatedly by the stationary phase. The components that are less strongly adsorbed move faster down the column, while those more strongly absorbed move slowly, and this leads to the separation of the component into distinct bands along the column. The separated compounds are then collected individually as the eluent from the bottom of the column. For example, a mixture of chlorophylls and the carotenoids from plant extracted can be used through the column chromatography, right? So in simple words, in column chromatography, what happens? The stationary phase is present in the funnel in this tube. So this is a column, this is made a column, and from top the mixture of two component is added, and slowly we get a compound from the lower side. Next is a TLC. TLC means thin layer chromatography. We also said TLC. This is TLC chamber. TLC. In this, TLC is a rapid and highly effective adsorption chromatography technique where the stationary phase is a thin layer, but typically about 0.2 mm thick of the adsorbent such as silica gel or alumina coated on a glass plate or plastic aluminum foil. A small spot of the mixture to be separated is applied near one end of the TLC. As you can see the spots, this is a TLC plate and this is the spots, right? A small spot of the mixture to be separated is applied near one end of the TLC plate. The plate is then placed in this closed TLC chamber containing a small amount of mobile phase, ensuring the solvent level is below the applied spot. When we applied here, the starting line for the solvent is here. That is not up the spots. The plate is then placed in a closed jar and ensuring the solvent level is below. So as the eluent rises up the plate, the capillary action, it carries the components of the mixture with the different components move at different speed based on their differential absorption to the stationary phase and the solubility in the mobile phase. This is TLC. And the relative movement of each component is expressed by retardation factor. This we used to say RF factor, which is the distance moved by the substance from the baseline x, we take this s, and distance moved by the substance from the baseline, and next the distance moved by the solvent from baseline, right? So after the solvent has moved a sufficient distance, the plate is removed and dried. As you can see here, the plate is removed, right? So colored compounds are visible. They move from this is their starting phase, right? So after this process, these points move upward, right? This is their starting line. So the colored components are visible as distinct spots. The colorless compounds, various detection methods are used, like for colorless is UV light. You can use UV light, iodine chamber, spray reagent. In UV light, what happen? Compounds that fluorescence under UV light can be observed. In iodine chamber, placing the plate in a jar with iodine crystal cause iodine to be absorbed by the compound, making them visible as brown spots. A spray reagent, a suitable reagent which is sprayed on the plate which reacts with the separated compounds to produce colored spots. For instance, amino acids, right? Amino acids can be detected by spraying in hydrogen solution. So TLC is widely used for monitoring reaction progress. Okay, what is the progress of reaction? Checking the purity of compound and identify the components in a mixture. Next is the partition chromatography. In this type of chromatography is based on the continuous differential partitioning of components of a mixture between two immiscible phases, that is a stationary one and mobile one. Paper chromatography is a common type of partition chromatography. Here the stationary phase is water trapped within the cellulose fibers of a typical chromatography paper. A spot on the mixture is applied near one end of the strip of chromatography paper. This strip is then suspended into suitable solvent or a mixture of solvents, allowing the solvents to rise up the paper by capillary action. As the mobile phase moves, the components of the mixture are continuously partitioned between the stationary phase and mobile phase. Components that are more soluble in mobile phase and less retained by the stationary phase will travel further up by the paper, leading to separation, and they develop the paper strip that is referred to as a chromatogram. Similarly, in thin layer chromatography, what happened? Colored in TLC, what happened? Color compounds are directly visible. Colorless compounds can be detected by UV light by appropriate spray reagent. In paper chromatography is a specific type of chromatography used for separating and identifying mixtures that are colored, particularly pigments. In paper chromatography, a spot of leaf extract is placed on paper made of cellulose fiber and water in its pores. The pigments from the leaves are extracted by crushing them with acetone solvent in a mortar and pestle, and the spot of leaf extract is placed at the, like this is the paper layer, placed at the center of the lower part of the paper, and with the help of the capillary tube, the mixture of the solvent such as petroleum, ether and acetone is taken into beaker, and the paper will be present in that beaker in which this is acetone, right? So with the leaf extract is placed into the beaker. After some time, what happened? Different colored spots can be observed on the paper at different distance from the site of the leaf extract. There is also distinguished solvent line, right? So this is paper chromatography. different colors can be shown on that paper, and the pigment migrate on the paper at different rate depending on their attraction towards the acetone and petroleum ether solvent. Means that depends upon the type of solvent, depends upon the type of interaction they have with that solvent. And the yellow color spot was identified as carotenoid, while the green one is for chlorophyll. And for the from the retention factor value, the retention factor is the RF factor is the ratio of the distance traveled by the solvent to the distance traveled by the pigment from the original line where the spot of leaf extract from placed initially. The value of the retention factor for each colored pigmentation is calculated, which can then be compared with the values already published. Now I will summarize all of the method. First is sublimation. Sublimation is used to purify solids like camphor that directly convert to vapor on heating, leaving behind non-sublimable impurities like sand or water, sand or salt. Crystallization separates solid based on their solubility. Difference in a suitable solvent like pure crystals from on cooling, while impurity remain dissolved or filtered out. Simple distillation and fractional distillation and vacuum distillation. Next is the differential extraction. Okay, distillation is left. Distillation is the what? The simple distillation separates volatile liquids from non-volatile impurities or another liquid with a significant different boiling point. Right. Fractional distillation is applied when boiling point differs slightly. Repeated condensation and vaporization is a fractionating column help in isolate compounds like petrol and crude oil. Steam distillation is isolate steam, volatile and water immiscible compounds like aniline or essential oil. Next is a differential extraction that we have discussed today. Is a separate organic compound from aqueous mixture using an immiscible solvent like ether. The compound migrates into the organic layer, which is then separated. And last is chromatography. Chromatography separates mixture based on differential absorption or partitioning between stationary and mobile phase. Thank you.